Hi, this week we're going to talk about investment decision and applications, and we're going to use the discounted cash flow criterion here. We're going to do several examples. We'll start with this one, where we're going to be evaluating two options that are available to us. An insurance company offers to settle a claim by making a payment of $17,000 immediately, or payments of $4,500 at the end of every year for 4 years. Assuming that money is worth 6.5% effective, what plan or which plan would you accept? And you cannot make a decision simply by comparing here the $17,000 cash payment immediately versus the $4,500 at the end of every year for 4 years. We have to bring them to a common denominator, or a common, we have to compare apples to apples. And if we make payments over time, what we have to do is reduce them to an equivalent value at the same time period. So let's take a look at the first option. The first option is $17,000 paid immediately. So if I was to draw a time diagram for that, I would have a single payment of $17,000 paid today. So that's option number one. What's the cash value of this option using 6.5% effective? And effective means compounded annually. Means compounded annually. Always remember that. So, well, this one's pretty straightforward because the present value of option number one is simply the cash value that it has. In other words, it's just worth $17,000 today, no more, no less. Now let's take a look at the second option. With the second option now, we're going to be comparing the cash payment to $4,500 paid at the end of every year for 4 years. So that's going to be a very simple, straightforward time diagram. I'm going to use the other timeline that's at the bottom of the page for this one. So we've got 0, 1, 2. I like to draw time diagrams because it helps me to put things into perspective. So I've got 4 payments of $4,500 at the end of every year. So that's an ordinary annuity, $4,500 at the end of every year. It's very simple to draw. And we have here an annuity with 4 equal payments. So we've got n is equal to 4 payments, and they are per year. And that's great because we have an ordinary simple annuity now, because we know that the IY is equal to 6.5%, and the compounding periods per year is equal to 1 because it's compounded annually, it's effective, and the payments per year are also equal to 1 because they are made per year. So the present value, or the cash value, of option number 2 is simply $4,500 per year multiplied by the present value factor for ordinary annuities, which is 1 minus 1 plus 0.65, 6.5% per year for 4 yearly payments, divided by 0.065 per year. And we'll work this out on our calculators, or we could use the built-in function on our calculators. Remember that payments per year are equal to 1. We also have the size of the payment is equal to $4,500, and the end value is equal to 4. So we can compute now the present value. And when you compute the present value of option number 2, you should get a value of $15,416.09. So I'm going to be comparing this value to the other value that we had with the cash payment. So what do we get? If we're going to round this off to the nearest dollar, I suppose, a lot simpler if we just use dollars. So this rounds off to 15,416. So I would compare this to the $17,000 cash payment. Which one do you think should be chosen or selected? Well, clearly the cash payment represents a higher value, or a higher present value. If I'm receiving the money, I would rather have the $17,000 in cash, because the cash value of the $4,500 per year reduces to a discounted or cash value of 15,416. So my preference would be to pick the $17,000. It represents a better return to you at 6.5% effective. Of course, your conclusion may have been different if you used a different interest rate, but we're sticking with 6.5% for our analysis at this time. You'll notice that this is kind of an interesting result, or an interesting outcome, because the total value of all of the payments in terms of their face value is $4,500 times 4, or $18,000 in payments over time. So we've received $18,000 in payment over time for the second option versus one single $17,000 payment made immediately or today. Still, the $17,000 represents a higher present value than the other option. That's what the present value formula does for us. It helps us to make an analysis where we can compare everything on the same basis.